In the previous lecture, we saw what are periodic and non-periodic signals. I said periodic signals are those signals which repeats itself after a regular interval of time, and the non-periodic signals or aperiodic signals do not repeat itself after a regular interval of time. And using this definition, we obtained condition for periodicity. In case of continuous time signals, the condition for periodicity says if a signal xt is periodic, then it is equal to xt plus minus n t naught, where t naught is the fundamental time period, n is any integer, and from this we can clearly see if you perform the time shifting, either left shifting or right shifting by n t naught, then you will get the same signal. The fundamental time period is the smallest and positive value of time for which the signal is periodic. The fundamental time period is the smallest period for which signal xt is periodic. This is the definition of fundamental time period, and this should not be equal to 0 and also should not be equal to infinity, and it is positive. So this is all about the fundamental time period. We have already discussed it in the last presentation. Now for discrete time signals, the condition for periodicity says if a discrete signal x n is periodic, then it should be equal to x n plus minus m into capital N, where capital N is the fundamental time period. This is all we discussed in the previous presentation, but there is one very important point you need to add in the definition of periodic and non-periodic signals, and we will try to understand this point by the help of one example. We will use the condition of periodicity to prove whether the signal xt is periodic or not. This is the waveform of signal xt, and we need to find whether xt is periodic or aperiodic, and we can do this by the help of definition we have. According to definition, if the signal repeats itself after a regular interval of time, it is periodic with a fundamental period t naught. Here you can see the signal is repeating itself after 0.5. We have 0 at 0 and again 0 at 0.5. In the same way, after 0.5 we again have 0 at 1. So the fundamental period t naught is equal to 0.5, t naught is equal to 0.5, and according to condition of periodicity, xt should be same as xt plus minus 0.5, or you can say n times 0.5. Let's say n is equal to 1, so xt should be same as xt plus minus 0.5 plus minus 0.5, and to check its periodicity, I will consider the condition in which the signal is shifting towards the left by 0.5. So we will take xt plus 0.5. We will obtain the waveform of this signal. So let's see how the waveform will look after performing the left shift. This is the waveform of xt plus 0.5, and if you compare the two waveforms, you will find in this waveform from minus 1.5 to 0 we have 3 triangular pulses, and from 0 to 1.5 we have 3 triangular pulses. But in this case, from minus 2 to 0 we have 4 triangular pulses, and from 0 to 1 we have 2 triangular pulses. This means x of t is not same as xt plus 0.5. xt is not same as xt plus 0.5, and this means signal xt is aperiodic. So we need to add something to our definition to make it correct. The signal is said to be periodic if it repeats itself after a regular interval of time, and the repetition of particular structure, triangle in this case, or value should be from minus infinity to infinity. So this point is very important. The repetition of a structure or value should be from minus infinity to infinity. So this point you need to add to your definition. Here in this case, the repetition was from minus 1.5 to 1.5. It was not from minus infinity to infinity, because of which when we performed this shifting, the signal changed. But if the signal is repeating from minus infinity to infinity, and if you perform the shift by any period, the signal is going to be same. So this point is very important. The repetition of the structure or value should be from minus infinity to infinity. So this is all for this lecture. This lecture was to explain the importance of repetition from minus infinity to infinity. And to understand this, by the help of an example, you can consider this waveform, and you may add triangular pulses like this from minus infinity to infinity. And now if you perform the shifting towards the left or towards the right by any period, not only by fundamental time period, you will get the same waveform. And in that way, the condition for periodicity will be satisfied. So this is all. I will end this lecture here. See you in the next one.